Hello and very welcome everyone to this session of the World Geography, Continents and Oceans Part 2. In today's session, we are going to discuss this topic and we'll learn some more important things that will help us in our upcoming exams. So let's start. Before we start, the images, text and other materials used in our presentations are for educational purpose only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathi@iitk.ac.in and we shall remove the same. So first, we need to discuss about the introduction of this chapter. So the 71% of Earth's surface is covered by water. So it is often referred to as the water planet or the blue planet as well. So that is about the Earth. So do remember that Earth is covered with 71% of water. And only 29% of Earth's surface is land. The northern hemisphere is referred to as the land hemisphere because it contains 61% land and 39% water, while the southern hemisphere is referred to as the water hemisphere because it contains 81% water and 19% land. 3,800 meter is the average depth of oceans, while the average height of the lithosphere is 840 meter. So do remember all these things related to the continents and oceans so far, and let's read more. Now let's talk about the major oceans. So Pacific Ocean is the largest ocean, followed by Atlantic, Indian and Arctic. According to depth, Pacific Ocean is deepest, followed by Indian, Atlantic and Arctic. So always remember, and also remember that Pacific Ocean is the oldest ocean. Earlier it was named as Panthalassa, and after the continental were drifted away and tectonic movements happened. After that, all these oceans came into form, and after that, the Indian Ocean, Atlantic Ocean, and Arctic Ocean, and all these are oceans formed. And now, total, we have 5 oceans in the world. The relief of the oceans. So, hypsographic or hypsometric curves are those curves that represents the different height and depth zones of the lithosphere and the hydrosphere. So these are the curves that defines the height difference and depth difference between the lithosphere and the hydrosphere, means the difference between the lithosphere, that is the crust, and the water level. The floor of the oceans may be divided into 4 parts according to the hypsographic curve: continental shelf, continental slope, deep sea plains, or oceanic deeps. Now, continental shelf is the seaward extension of the continent from the shoreline to the continental edge. So, continental shelf is basically represents that part of the major relief feature of oceanography or oceanic landforms, in which when we start moving from continent towards ocean, so first thing that we see is known as the continental shelf, and the gradual degree of this shelf is approximately equivalent to 1 degree, and after that it is the next major relief that comes is the continental slope, and that has a more inclination with respect to the continental shelf. Average width of continental shelves is 80 kilometer. Average depth of continental shelves is 150 to 200 meter, and slope is 1 degree, as I was saying. The relief of the coastal land decides the width of continental shelves. They are wider shelves, they present where coastlands are wide plains. So this is also, remember that this is the first major relief of the ocean. Let's move further. Then comes the narrow shelves. So the narrow shelves are narrow where the high mountains are very close and parallel to the coast. Example, due to the presence of Andes mountain, The Pacific continental shelf along western coast of South America is 16 kilometers narrow. These shelves have the richest fishing grounds in the world. For example, Dogger Bank in the North Sea, Grand Banks of Newfoundland. 7.6% of the ocean floor is occupied by the continental shelves. So, shelf is a very important part, and always remember that it is the Arctic Ocean which has the most exclusive continental shelf. Then comes the continental slope. So continental slope is the region of steep slope that extends from the continental shelf to the deep sea plains. So first, when you start moving from continent toward ocean, the first thing that comes is continental shelf. Then the angle of degree is more inclined, and then comes the continental slope, and that continental slope finally merges into the deep sea plains that are also known as the abyssal plain of oceans. Submarine canyons are the major significant relief feature of continental slope. 8.5% of the total area of the ocean basin is occupied by this slope. Variation of its gradient from 2 degree to 5 degree, as I was saying. So the inclination increases as we move from continental shelf to continental slope. Over continental slopes, the depth of water varies from 200 meter to 3000 meter. Then comes the deep sea plains. So 75.9% of the total area of the ocean basin is occupied by this plain. Hence, it is the most extensive relief zone of the ocean. The depth of water varies from 3000 meter to 6000 meter. And some significant relief features are ridges, guyots, seamounts, trenches, etc. So that is the average depth of deep sea plains, that is from 3000 meters to 6000 meter. And if we talk about the deep sea plains, so they also have some minor relief features like ridges. Ridges are nothing but the mountains or the part of lava that comes out from the ocean floor and the form of lava and cool down and create ridges. Then comes the guyots, seamounts, and trenches. Then oceanic deeps. So oceanic deeps are indicated to the depressions and trenches on the ocean floor. Oceanic deeps are the deepest zones of the ocean basin and cover about 7% of the ocean basins. Oceanic deeps can be divided into two categories according to their size. Deeps, they are very deep but less extensive depression. Trenches, they are long but narrow linear depressions, major oceanic trenches. So these are the oceanic deeps, and there is something related about it. Now let's discuss about the major ocean trenches. So here we can see that the first one is the Mariana Trench, and the depth is 11,034 meter. That is approximately 11 kilometer, and it is found in the North Pacific Ocean, and to be precise, it is found near the Philippines. And trenches are that minor relief feature of the oceans that are found in the oceans that were formed because of the convergence of two tectonic plates in the ocean at the oceanic floor. So Mariana Trench is the deepest trench in the world. Then Tonga or Aldrich Trench, it is 10,882 meter deep, and it is also found in Pacific Ocean but in the central South Pacific Ocean. Then Ramapo, Japan, it is 10,554 meter deep, and it is found in North Pacific Ocean. Then Kurile, it is found at a depth of 10,542 meter off Sakhalin, Kamchatka, Pacific Ocean, that is in the northern part of Pacific Ocean. Then Mindanao, it is 10,497 meter deep, and it is found in Pacific Ocean. Sur, that is Philippines, 10,475 meter deep and found in Northwest Pacific Ocean. Then Kermadec, 10,047 meter deep, and it is found in Pacific Ocean. So these are the major oceanic trenches. some more. So Puerto Rico, that is the deepest trench of Atlantic Ocean, always remember, and it is found in the Atlantic Ocean. Then Diamantina, it is for 5,800 meter deep, and it is found near in the Indian Ocean. Then Aleutian, it is 8,109. It is found in Pacific. Then Cayman, 7,686 meter, found in Atlantic. Atacama, it is 8,065 meter deep and found in South Pacific Ocean. Romanche or Tizard, it is 7,758 meter deep and found in South Atlantic Ocean. Then comes the Java Trench, or it is the Sunda Trench. The depth is 7,290 meter and it is found in East Indian Ocean. And do remember, this is the deepest trench of the Indian Ocean. Now here you can see the distribution of water on Earth. So in this you can see the diagram that how the water is present on the earth, that all the water that is present, 97% is ocean and 3% is fresh water. Then if we talk about the fresh water, so fresh water 3%, and now if we look at that, so ice caps and glaciers are 79% in that, and groundwater is 29%, and accessible surface fresh water is only 1%. And the accessible surface fresh water is further subdivided as in the form of soil moisture, that is 38%, water vapor 8%, rivers 1%, water within living organisms 0.8%. So this is the distribution of water on the surface of the earth. So here you can see that oceans consist of 1370 10 lakh cubic kilometer of water, and that is 97.25%, but it is of no use because we cannot use it for drinking purpose. Now glaciers and ice caps, they consist of 29 10 lakh cubic kilometer, that is approximately 2.05%. Then groundwater 9.5 10 lakh cubic kilometer, that is 0.68%. Lakes 0.125, 0.001. Then soil moisture, you can see the constituent in cubic kilometer and the percentage is 0.005. Atmosphere 0.013 10 lakh cubic kilometer and 0.001 is the percentage in total. Rivers 0.0017 10 lakh cubic kilometer and 0.0001% is only available in the form of rivers. Then biosphere 0.0006 in the form of volume, and in terms of percentage, that is only 0.00004. So this is the distribution of water on the surface of the earth. Now let's talk about some important feature of reliefs, and these are also known as the minor reliefs. So do remember, if we are talking about the major reliefs of the oceans, so we will start from the continental shelf, then comes the slope, then the abyssal plain. So these are the major relief features in the oceans. But if we talk about the minor relief features, so let's take a look. So submarine canyons. Submarine canyons are basically the steep-sided erosional gorges which cut into the continental slope, sediments and rocks of the shelf. Some important examples are Congo Canyon, Nazare Canyon, Hudson Canyon, Bering Canyon, Monterey Canyon, etc. So these canyons are found on the continental slope, and they are starts on the surface and reaches the oceans. And that is why they are the part of the minor relief features of the oceans, and they are found on different continents all over the world. Then oceanic ridges. These are the most extensive in the Atlantic and the Indian Ocean. Oceanic ridges are a long elevation of deep sea floor having less regular topography than a rise and steeper sides. Above the ocean surface, they form islands at many places, such as Azores Islands. So these are called the oceanic ridges, and I already told you that oceanic ridges are formed when the divergence of plate take place, and because of the divergence the the lava comes out on the surface on the ocean floor, and as soon as it cools down it starts creating a mound of ridge that is called the oceanic ridge. The longest oceanic ridge in the world is found in Atlantic Ocean. Here you can see this is the map, and it defines the different type of zones on the basis of the temperature distribution according to the climate. So let's take a look of it and let's see further. So first we are going to discuss about the oceans in details now. So first one is Pacific Ocean, that is the largest ocean of all the oceans. Earth's one-third area is occupied by it, and I already told you that it was also the oldest ocean in the world. Overall shape of the Pacific Ocean is triangular. If you start from the North Pacific and you move towards the South Pacific, you can see that the whole area of Pacific Ocean is covered in triangular shape. In the east coast of Asia and in the west to west coast of America. In the east, it extends 16,000 kilometers from east to west. It extends 14,880 kilometers from north to south between the Bering Strait in the north to Cape Adre, that is Antarctic, in the south. Marginal seas are found on the western margin of the Pacific Ocean. On the eastern side of this ocean, the Gulf of California is the only marginal sea. Example, Coral Sea, Sea of Okhotsk, Bering Sea, Sea of Japan, Yellow Sea, China Sea, Bass Strait, Arafura Sea, etc. So, if we talk about these important seas that are sharing their boundaries or water with the Pacific Ocean, out of all of them, remember that South China Sea, this is the largest sea in the world as well, and you can find it on the merging with the Pacific Ocean in the eastern side of this ocean. So this is all about the Pacific, and do remember these are some of the important points. Bering Strait is also another important point that divides or separates the America from the Russia or the Asia. Remember that as well. East Pacific rise. Central or mid-oceanic ridges are not found in Pacific Ocean. So there is no central or mid-oceanic ridges that clearly defines that there is no divergence boundary found in the middle part of Pacific Ocean floor like the Indian and the Atlantic Oceans. However, few scattered ridges are found here. Albatross Plateau or the East Pacific ridge of it. Albatross Plateau extends from north of New Zealand to California coast. Pacific ridges and rises name. So first is the Bonin. So this is one important ridge found in Pacific. Then Fanning. Then East Pacific, Hawaii, Macquarie, and Fiji. So these are some of the important ridges found in the Pacific, and their names are written. Some important trenches and basins of the Pacific Ocean. So Japan is the deep sea trenches. Mariana is another one. Aleutian is another one. Chile, Peru, Philippines, Curili, Tonga, Karamadec, and Ryukyu. Then deep sea basins are Tasman, Central Pacific, Coral, Celebes, Banda, Fiji, Philippines, Caroline, South Pacific, and Peru. So these are some other trenches and basins. Now, Atlantic Ocean is the one we need to talk about. So 1/6 of the total area of the Earth is covered by the Atlantic Ocean. This ocean has an area of 106,460,000 kilometer square, which is about 50% of the Pacific Ocean. So if we talk about Atlantic, so do remember this is the second largest ocean in the world. The shape of the Atlantic Ocean is S. If you look into the map, the world map, you will find that if you start from the Iceland country in the North Atlantic and you move towards the Antarctic in the Atlantic Ocean, and if you try to mark it with the pen, then you can create the letter S on that. So that is why it is found in the S shape, and it narrows towards the equator while it widens to the south of the equator with the maximum width of 5,920 km at 35-degree latitude. So this is the point where has the maximum width. But in between the Liberian coast and the Cape Sao Roque, it is only 2,560 km wide. Marginal seas are Hudson Bay, North Sea, Baltic Sea, Mediterranean Sea, Baffin Bay, Davis Strait, islands on the Atlantic Ocean. Atlantic Ocean contains a few islands such as, we will talk about it, but first of all, marginal seas, I hope now you are able to understand those seas which are found just adjoining with the passive with any particular ocean. So these are all the seas that you can find either joining the Pacific, either joining the Atlantic or in the near about area. So islands that are found in the Atlantic Ocean are Georgia, Sandwich, British Isles, Falklands, South Orkneys, Shetlands, St. Helena Islands, and Newfoundland, etc. So these are some of the important islands that are found in the Atlantic Ocean, and you can mark them in the Atlantic Ocean from north towards south. And we all know that Greenland is found in the northernmost point of the Atlantic Ocean, and it touches the Atlantic as well as Arctic on the north side, and it is the largest island in the world. Now, Atlantic Ocean, deep sea basins, ridges and rises. So, deep sea basins, ridges and rises. Deep sea basins are Brazil, Agulhas, North America, Cape Verde, Sierra Leone, South Antilles. And ridges and rises are Rio Grande, Sierra Leone, North and South Atlantic, Walvis, and Guinea. Some other deep sea trenches, Romanche Trench, Wama Deep, Buchanan Deep, Columbia Deep, Moselle Deep, Cayman Trough, Valdivia Deep, Puerto Rico Deep, Hatteras Deep, and Neres Deep. Now, let's talk about one of the important feature or minor relief feature of oceans, that is the Mid-Atlantic Ridge. Mid-Atlantic Ridge is extended for 14,400 km from Iceland in the north to Bouvet Island in the south and has an S-shaped structure. In the bottom relief of the Atlantic Ocean, the presence of a longitudinal mid-Atlantic ridge is the most characteristic feature. It has many branches like Challenger Rise, it is present to the south of the equator. Dolphin Rise, it is present to the north of the equator. Wivley Thompson Ridge, it is present in between Iceland and Scotland. Telegraphic Plateau, this plateau is situated to the south of Greenland. Newfoundland Rise, it is a branch of the Central Ridge, lies near 50° north latitude. And Azores Rise, it extends up to Azore Islands and bifurcates from the mid-Atlantic Ridge to the south of 40° north latitude. Walvis Ridge, it spreads from Tristan da Cunha to the west coast of Africa at 40° south latitude. Rio Grande Rise, this ridge extends up to South American coast. The higher parts of the Mid-Atlantic Ridge, rising above the water surface, are as follows. The Azores in the north, Ascension and Tristan da Cunha Islands in the south. Pico Islands of Azores. It is the highest island peak of the Azores, which raises 213.36 meter above sea level and 8,229.6 meter above the sea floor. So this, remember that Pico Island of Azores is the highest island peak of Azores. And these are some of the important ridges and islands that you can find in the Atlantic Ocean. Now let's talk about the very important one, Indian Ocean, and the only ocean that is named after a country. So it is smaller than Atlantic and Pacific Ocean. 22% of the total area of all the oceans of the world is covered by it. on all of its sides is bounded by Asia in the north, Africa in the west, Asia in the east, Australia in the southeast, and Antarctic in the south. So if you take a look at the map, you can find all these continents sitting on the basis of this statement. Andaman Sea is the basin enclosed between the Andaman Nicobar Arc and the Kra Isthmus. Central Ridge, it is also known as the Mid-Indian Oceanic Ridge, and it extends from the southern tip of the Indian Peninsula in the north to Antarctic in the south. Now, branches of Central Ridge, so Seychelles, Mauritius Ridge, Socotra Caigos Ridge. It is also known as the Carlsberg Ridge, Southwest Indian Ridge, Madagascar Ridge. I hope you all know Madagascar. It is the largest island of Indian Ocean. You can find it on the eastern side of the African continent, and it separates with the Mozambique Channel with the country called Mozambique. Prime Edward Crozet Ridge is the southward extension of it, which lies between 40 degrees south to 48 degrees south latitudes. 90 East Ridge. It merges with Amsterdam St. Paul Plateau and extends up to the continental shelf of the Irrawaddy River mouth. The length of the ridge is almost 4,000 km long. In the south, it joins with West Australian Ridge or the Broken Ridge. Kerguelen is the western branch of it. The central ridge bifurcates to the south of 50 degrees south latitude. Eastern branch of the central ridge and Gaussberg Ridge is also known as the Indian Antarctic Ridge. So these are some of the very important ridges and branches that are found in the Indian Ocean. Islands, as compared to the Pacific and Atlantic Ocean, it has far less number of islands. Some of them are as follows: Madagascar, Sri Lanka, Socotra, Maldives, Caigos, New Amsterdam, St. Paul, Kerguelen, Mauritius, also known as the volcanic island, Reunion or volcanic island, Laccadives, etc. So these are some of the very important islands that are found as compared to the Pacific and Atlantic, but in the Indian Ocean. Though the number is less, but they are found in this region. And as I said, Madagascar is the largest island that exists in the Indian Ocean. Now, branches of Central Ridge. So, Indian Ocean Deep Sea Basin, ridges and deep sea trenches. So, deep sea basins are like Arabian, Indian, Australian, Somalia, Madagascar. Ridges are Southwest Indian Ridge, Crozet, Carlsberg, Mascarin, Diego Garcia, 90 East, Kerguelen, Gosberg, Macquarie. Deep sea trenches are Amirant, Nicobar, Sunda, Ob. Now let's talk about the another ocean, that is the Arctic Ocean. So the shape of the Arctic Ocean is almost circular, that surrounds the North Pole of the Earth. So if you go uh, towards north from the Asia and reaches the Russia, then after moving towards more north of Russia, you will find the Arctic Ocean. Total area of the Arctic Ocean is about 14 million square kilometer. By land masses, it is surrounded on all sides. Hence, there are a few places where it is connected with the Pacific and Atlantic Oceans. It is connected with the Pacific Ocean through the Bering Strait at 170 degree west. So Bering Strait is fine dividing or separating the North America, or you can say the Alaska from the Russia, or you can say the Asia, and that connects the Pacific Ocean to the Arctic Ocean. By a central ridge and Alice Mare Land, it is divided into two basins. Central ridge extends from the front Novosibirsk Island through the North Pole to Greenland. It is also named as Lomonosov Ridge and has a length of 1800 km. Arctic Ocean, marginal seas and islands. So marginal seas are like Eastern Siberian Sea, Beaufort Sea of Alaska, Barents Sea between Norway and Spitsbergen, then Laptev Sea along Siberian coast, Kara Sea between mouth of river Ob and island of Novaya Zemlya. Then islands we have New Siberian Island, Bear Island, Canadian Archipelago, Novaya Zemlya, Jan Mayen, and Spitsbergen. So these are some of the important islands and marginal seas that you can find in the Arctic Ocean. Ridges and basin. The geographic North Pole is located in the Farm Basin, which is 2, 3, 4, 5 fathom deep. Fathom is the unit of measuring depth of the oceans. It is surrounded by Nansen and Lomonosov ridges. Now, let's talk about one very important point, that is the salinity of the ocean. So we all know that oceans are saline in nature. The water of ocean is saline. And now let's see that why it is saline and what is the percentage of salinity that we can find in different oceans and seas at different latitudes. So changes in ocean water salinity with depth in the summer. So in this diagram you can see that equator is the point where you can see from equator towards right the salinity is shown increasing, and if we talk about the poles, so towards pole it is quite decreasing. And if we talk about the depth also, so with depth also the salinity also different, found different. So let's talk more on this. So salinity is the degree of saltiness in water. So it also being measured in ppm, that is the parts per molecule. So whatever amount of ppm is found in water, on the basis of that the salinity is defined. Due to free movement, salt remain remarkably constant in all oceans and even at great depths, but degree of concentration varies. NaCl or common salt from 77% of dissolved mineral matter, and other salts include magnesium, calcium and potassium. Average salinity is 35.2 parts per thousand, as I was saying. So ppm or ppt is the form in which you can measure the saltiness of a water. Now the salinity of some famous seas. So Red Sea, it is much surface evaporation and fewer rivers draining into it. Salinity is 39 parts per thousand. So salinity majorly depends on two very important phenomena. One is the evaporation of water, and another one is the availability of the fresh water, that is the inlet of fresh water from the rivers. So if we talk about the Red Sea, so evaporation and fewer rivers draining into it, because of that the salinity is 39 ppt. Dead Sea, its salinity is around 250 ppt. That means it is the most saline body or water body that is found on the earth. Also remember, the Dead Sea is the lowest point on the earth's surface. Baltic Sea, it is dilution of fresh water and has salinity of 6 to 20 parts per thousand. So you can clearly see that Baltic Sea is found on the higher latitudes, that is besides the 50-degree north latitude, 60-degree north latitude, and you can see that the salinity in those areas is different because the evaporation is not very much high and the availability of fresh water in the form of ice and rivers is available. Caspian Sea, enclosed sea with salinity at 180. So also we all know that Caspian Sea is found in the Central Asian part, and that is why we can see that it is also being saline. But always remember that the most saline water body is Red Sea. Lake Van or Asia Minor. Lake Van at 330 highest salinity. It is in terms of lake, but in terms of sea, if we talk about, that is the Dead Sea. And Lake Van or Asia Minor has the 330 highest salinity. Due to the high density in Lake Van and Dead Sea, it is impossible to sink. So beginner swimmers find it easier to float. So that is another important fact, that the more the salinity in the water body, it is will be harder to sink into the Dead Sea. And because of that, for the beginners, the people who are learning swimming, and for them as a beginner, it is quite not very easy to learn swim in this type of water bodies. Salinity of oceans. Salinity is affected by following factors. Fresh water is added by precipitation, streams, and icebergs. Salinity is low in the equatorial region due to heavy rainfall and high relative humidity. Baltic, Arctic, and Antarctic waters have low salinity due to colder climate and little evaporation, as water is added by melting of icebergs and rivers. Rate of evaporation. Water fringing the high pressure belts of trade wind deserts have high salinity caused by high temperature and low humidity. Temperate oceans have low salinity due to lower evaporation and temperature. So always remember that wherever you will find less rainfall and high temperature, in that case the salinity will be high. So that is around the areas of subtropics you can find this thing, but in the temperate region you can find the less salinity. Degree of water mixing by currents. So water does not mix freely with ocean waters in enclosed seas and salinity is high. Factors increasing or decreasing salinity. Increasing salinity, first is the ice formation, second is the evaporation, third, solution of salt deposits, mixing with more saline deep water, surface circulation, advection of more saline water. Now, decreasing salinity, ice melting, precipitation, inflow of fresh water from land, mixing with less saline deep water, surface circulation, advection of less saline water. So these are the different points that defines or factors that defines the increment and decrement of salinity in the sea and oceans. Significant salts of the seas. So salts are like sodium chloride, that is 27.213 per 1000 gram of water, and percentage is 77.8. Magnesium chloride is 3.807 and percentage is 10.9. Magnesium sulfide is 1.658 and percentage is 4.7. Calcium sulfate is 1.260 and percentage is 3.6. Potassium sulfate is 0.863, percentage is 2.5. Calcium carbonate 0.123 and percentage is 0.3. Magnesium bromide 0.076 and percentage is 0.2. Total is the 35 percentage per 1000 gram of water and 100 percentage is the value. So significant salts of the oceans are defined in this percentage proportion. Now, another important point that we need to understand about ocean is the temperature of oceanic water. So here you can see this diagram shows the different zones that are created with the depths in the ocean, and as we start move from the top layer or the sea surface or the ocean surface to the sea floor or the ocean floor, the temperature keeps on decreasing. And let's see more about it, that at what point which type of zone is created. So the temperature of the ocean water is important for marine organisms including phytoplanktons and zooplanktons, that are animals. So these are the organisms that creates the ecosystem based majorly of the oceans, and the ocean temperature is highly affecting their sustenance. The temperature of ocean water also affects the climate of the coastal areas. The daily range of temperature of surface water of ocean is insignificant as it is only 1 degree Celsius. Maximum temperature is recorded at 2 p.m. and minimum temperature recorded at 5 a.m. in the morning. In the northern hemisphere, the maximum and minimum annual temperature of ocean water is recorded in August and February respectively. So that is regarding the different temperature at different point. So that is all the data regarding the temperature at different timings. Annual range of temperature is much smaller, less than 12 degrees Celsius for open seas, but there are regional variations. Cold current, as Labrador current reduces surface water temperature, and warm current like North Atlantic drift raises the temperature, making Norwegian coast ice-free year around. So because of this type of mixture, the Norwegian coast becomes ice-free. But also that one more point that exists here is that large amount of fish are also found in this region. Highest water temperatures are seen in tropics, Red Sea with 30 degrees Celsius to 38 degrees Celsius. Temperature varies vertically with increasing depth. 80% ocean water has temperature 35 degrees Fahrenheit to 40 degrees Fahrenheit. So that is the data regarding the temperature, that at which point and at which timing which temperature is found. Based on temperature, there are two types of currents. One is the cold currents. So bring cold water into the warm water areas. These currents are usually found on the west coast of the continents in the low and middle latitudes in both hemispheres, and on the east coast in the higher latitudes in the northern hemisphere. So cold currents are those basic currents that flow from the polar areas towards the uh, tropical areas or the temperate areas, and they are basically the cold currents as they flow the cold water towards the tropical regions, and majorly they are found on the western side of the continents. Now warm currents, so bring warm water into the cold water areas, usually observed on the east coast of continents in the low and middle latitudes in both hemispheres. In the northern hemisphere, they are found on the west coast of continents in high latitudes. Based on depth, there are two types of currents. Surface currents, upper 400 meter of the ocean constitute about 10% of water in the ocean. Deep water currents constitute 90% of ocean waters. Here you can see these are the different ocean currents which are famous all over the oceans, and those are in red are basically warm, and the one in blue are basically cold currents. And some are the permanent currents that you can find near the equatorial region and the circumpolar region. So let's talk first of all about the cold currents. So name, ocean, and descriptions are given. So let's read one by one. So California current that is found in North Pacific Ocean. Southwards flowing current of the west coast of the United States in the Pacific Ocean. Then Canaries current that is found in North Atlantic Ocean. The Canary current is a wind-driven surface current that is a part of North Atlantic gyre. Then Humboldt current, South Pacific Ocean. The Humboldt current is also known as the Peru current, flows north along the western coast of South America. Then Labrador current, that is the North Atlantic current ocean, and flowing from the Arctic Ocean south along the east coast of Canada. Some more cold currents, and that the first one is Oyashio Kamchatka current, found in the North Pacific Ocean. Oyashio, or the Kurili current, is a cold subarctic current, ocean current that flows south in the western North Pacific Ocean. Then West Australian current, Indian Ocean. It is found in Indian Ocean. It is cool surface current at the Southern Ocean and Southern Indian Ocean. Then the West Wind Drift that is found in the South Pacific Ocean. Surface oceanic current encircling Antarctic and flowing from west to east. Then the warm currents. So Agulhas current is found in Indian Ocean. The Agulhas current is the western boundary current of the southwest Indian Ocean. It flows down the east coast of Africa. Then Alaska current, North Pacific Ocean, southwest warm water current of the coast of Alaska and west coast of Canada. Then Brazil current, South Atlantic Ocean, flows south along the Brazil south coast to the mouth of the Rio de la Plata. Then East Australian current, that is found in the South Pacific Ocean. The East Australian current is the southward western boundary current that is formed from the South Equatorial current, crossing the Coral Sea and reaching the eastern coast of Australia. Then equatorial current is found in Pacific Ocean. Equatorial current, ocean currents flowing westward near the equator, predominantly controlled by the winds. Gulf Stream, very important one, that is found in North Atlantic Ocean. Warm ocean currents originating in the Gulf of Mexico along the east coast of the United States. Then Kuroshio current is found in North Pacific Ocean. North flowing warm current of the coast of Japan in the Pacific. North Atlantic Current that is found in the North Atlantic Ocean, and the North Atlantic Current forms the western boundary within the Atlantic Ocean that extends the Gulf Stream northeastward. Then North Pacific Drift that is found in North Pacific Ocean. The North Pacific Current is a slow, warm water. Now let's talk about the movements of ocean currents. So circulate in a regular pattern. That is a important point, and because of that the climate is also defined all over the earth. Warm current flows from the equatorial region to poles. It is very simple that the warm water will find the areas in the polar side, and that is why they will try to move. The cold current flows from the polar regions to the equator and have low surface. So it is kind of the exchange of these water currents, as the cold water or the cold current, when it starts flowing towards the warm water surface, so it will balance the area, and in the depth of the ocean the warm water current will move towards the polar areas. Underlying factors: temperature: warm water is lighter and rises while cold water is denser and sinks. Salinity: water of high salinity is denser than water of low salinity. Low salinity water flows on the surface of waters, and high salinity water flows at the bottom. So that is quite simple thing, because the salinity defines the density of the water, and on the basis of that the current will also flow. Then planetary winds, that is another factor that defines the movement of ocean currents. So trade winds, which move equatorial water poleswards and westwards and warm eastern coast of continents. Example: south equatorial current warms eastern coast of Brazil as warm Brazilian current. Westerlies in temperate are less reliable than trade winds, results in northeasterly flow of water in the northern hemisphere. So the Gulf Stream is driven to western Europe. So these are some of the important factors because of which the ocean current flows in the particular area or the oceans. Now the movements of the ocean currents. So landmass obstructs and diverts a current. So example: tip of South Chile, divert west wind, drift northward as Peruvian current. So that Peruvian current becomes is famously known as the cold current, and that is the point which reaches the western side of the South American continent near the Chile, and it creates the driest desert in the world, that is the Atacama Desert. Earth's rotation and influence of Coriolis force: it deflects freely moving objects including ocean currents to the right. In the north hemisphere it is clockwise, Gulf Stream and Canaries current, while in the south hemisphere it is anti-clockwise, that is the Brazilian current and west wind drift. Ocean resources. Potassium is also one of the most abundant minerals like salt, although potassium cannot be directly extracted as salt. Then sand, the sea beaches can be understood as the residual deposits of sand. Then salt is chemically known as the sodium chloride. It is one of the most abundant minerals found in the ocean water. Salt can be either directly extracted or could be mines, depending upon different regions. Then manganese nodules. These nodules contain enormous amount of metal wealth. They can be looked upon as a huge potential to be used by human beings as a resource, as and when technology is developed for harnessing these valuable metals. Other resources: gold and diamonds, limestone and gypsum, oil and gas. So these are the important sources or resources that we can find in the oceans, and they particularly flow from one side to other side because of the ocean currents. Waves are oscillatory movements that results in the rise and fall of the water surface. They are actually the energy, not the water as such, which moves across the ocean surface. So do remember that this is the energy because of which these waves are generated, and they are the oscillatory movements in the oceans. Waves and ocean currents are horizontal movement of ocean water. Tides are vertical movement of ocean water. So tides is the phenomena in which the level of water rises because of the pull of gravity of moon and sun, and that causes the spring tide and neap tide. But the waves and oceans are basically the horizontal flow or movement of ocean water. Now, wave speed, so rate at which wave moves measured in knots. Wave frequency, number of waves passing a given point during 1 second time. Wave amplitude, one half of the wave height. So these are some of the key factors related to the waves that are defined in terms of speed, frequency, and amplitude. Now tides. Tides are the periodical rise and fall of sea levels caused by the combined effects of the gravitational forces exerted by the moon and the sun, and the rotation of the earth and associated centrifugal forces. Spring tide and neap tide comes twice a month. Spring tide comes at full and new moon. Neap tide comes in the first and third quarter of the moon, in which the low tides are found, and spring tides are the high tides are found. Tides help in navigation, desilting, fishing, and generation of electric power as well. So these are the terms related to the tides, and tides are caused because of the gravitational pull of the moon and the sun in terms of the linear proportion in which they are exerting the force, and in terms of 90-degree angle also. Spring tides, when sun, moon, and earth are in a straight line, occurs on full moon day and new moon day. Highest high tide occurs. Neap tide, a period of moderate tides when the sun and moon are at right angles to each other. So these are called a neap tides. Surges, the movement of water caused by meteorological effects, that is caused the surges. Ebb, the time between the high tide and low tide when the water level is falling. Flow or flood, the time between the low tide and high tide when the tide is rising, that is called the flow or flood. That's it in this session. I hope you learned a lot of things with me in this session and gained great knowledge. I will meet you in the next session and we'll discuss more on this topic. Till then, bye bye and thank you.